Now, whenever you have a quotient of two other functions for which derivatives exist, you use the quotient rule to find the derivatives of that function. And the quotient rule is basically just this: v dash equals vu dash minus uv dash over v squared. And as long as you just find the derivatives correctly and substitute the figures into this formula, then that is basically it. You are home free. So we'll just do a quick example about the quotient rule here. Say if y equals x over 2x plus 5. Now in this situation you know that this is where you have to use a quotient rule easily. You could possibly use a product rule if they had some kind of multiplication going on over here, but since they don't, you don't have to worry about the product rule at the moment. Let's focus on the quotient rule. And if say find y dash, so this is how you go. First of all, you find out what u is and v is. So u is the x, which is the top figure here. V would therefore be the denominator, which is 2x plus 5. Now you take the derivative of u and you are left with 1. Take the derivative of v dash and you are left with 2. Now that is half the work done right there. The rest, all you have to do is just substitute all of this in. So u v dash so uv dash, I've just done it the opposite way, minus vu dash over v squared, which is 2x plus 5 squared. And don't make the mistake of just simply cutting this and this out here, as some people might do. Yeah, I know you might be tempted to do that, but do not do that. A good way of really knowing this is imagining that this whole thing is in a parentheses, so you know that you have to take care of this first before you go anywhere else. So this is just literally going to be 2x, so you can have, I'll do it here, 2x plus 5 minus 2x over 2x plus 5. So you know you have to cancel this out and you are left with 5 over 2x plus 5 squared, and you're done. And in some questions, if they ask you to find the derivative at a certain coordination, say 1-4, after that you just need to feed in the x figure inside and you have the answer. But for all intents and purposes, this is how you tackle derivatives using quotient rule.